Hello, welcome. Let's try to solve another Leetcode problem 3215 called Triplets with even XOR set bits 2. So for this problem, we are given three integer arrays A, B, C, and we're going to return the number of triplets AI, BI, and CK such that the bitwise XOR between the elements of each triplet has an even number of set bits. So let's just use the example 1 to understand the problem. So we're going to choose each number inside of the array. It's going to be A0, B0, and C0. Basically, we're going to calculate the XOR operation of 1, 2, 3. So it's going to be 0. So the number of set bit is 0 because the set bit is 1. Yeah. So if it is 0, so there's only one possible case. It is 1. And in the second example, there are going to be 4 different cases. So, yeah, we're gonna, as we can see, 0, 1, 0, 1, 1, 0, 0, 0, 1, and 1, 0, 1. It's going to be 4 different cases, so we're going to return 4. So if we use brute force, definitely we're going to choose each number inside of the array A, B, C, and we're going to check the formula. If it meets the condition, we're going to plus 1. So the time complexity is going to be n cubic. But this n going to be 10 to the power of 5. Definitely it didn't work. Yeah. Now we're going to use the mathematics skills to solve the problem. So what important for us is that we are calculating the set bits. So for example, we have 1, 1, 1, 1 with a set bit of 1, 1, 1, 1. We're going to do the XOR operation. So if there are 2 numbers, but we have 3 numbers, if it is like that, maybe. Yeah. So for each of the number of the set bits is even. So it means the number of set bits modulo 2 equal to 0 for all of them. This one, and this one. So for all of them, the number of the set bits is even. So if we do the XOR operation, what's going to happen? This one, we're going to eliminate it. And what left behind is 1, 1, 1, 1. So the number of set bits is going to be 4. 4 modulo 2 going to be equal to 0. So this means for any number inside ABC, if those 3 numbers, if all the set bits is even, so basically it is possible. So we're going to count it as 1. So this is a valid case. Yeah, maybe you think why we're going to calculate it like that. Maybe we're going to calculate, maybe it is not the same value. Maybe we're going to calculate it like others. Maybe this 1, 1, this is even, this is 1, 1, and this is 1, 1. So what is the final result? So this is 1, this is 0, 0, 1. So the number of set bits is still 2. But how can we prove that? Yeah, we can prove it like this. So if we have some numbers like 1, 1 or 0, 1, 1, it doesn't matter. So this is 1, 1, something, 1, 1. Or here is 1, 1, something, yeah, 1, 1. We're going to do the XOR operation for all of them. So the idea is that, for example, this is a 0. Yeah. Maybe this is 0, and here is 0. So the idea is that we're going to do the XOR operation for the set bit. So for example, at this position, we're going to do the set bit. If this is a 0, this is 1, this is 1, this 1 going to become 0, and this 1 going to become 0. So how many ones we reduced? 2. Right. Yeah, so this means if the total number of the set bit is even, and each one of them is even, if we do the XOR operation, yeah, so what I mean is that if the total number of set bits is even, so this plus this one is even. So it's going to have 2 different cases. One case is each one of them is even. So this is also valid. As you can see, each one of them is even. The set bit is even. If we do the operation, if each one of them even, we do the operation, we're going to reduce 2 ones at the same time. If we do an operation, we're going to reduce a 2, we're going to reduce a 2. So for such number, if this is an even number, we're going to reduce minus 2, minus 2, minus 2. It's going to always be an even number. Yeah. So this is one case. So another case is that 2 of them is even. So for example, we have 5 ones. This one, we're going to have like 5 ones. If 2 of them is odd and 1 of them is even. So we have 4 ones, here we have 5 ones, here we have 5 ones. Yeah, so this means the total number of set bits is still even, but we have another case. So 2 of them is odd, another one is even. This is the second case, and we cannot find a third case because that is not possible. So if 2 of them is odd, another one is even. If we do the XOR operation, so for example, maybe this one and this one, we do the XOR operation. We're gonna reduce the two at the same time. Yeah, 1 1, we're gonna 1 1, it's gonna become 0 0, we're gonna reduce the 2. So the total number gonna minus 2, because total number is even, minus 2 is gonna be even. Yeah. So what happens is that if this is a 0 and here this is a 1, what happens? Yeah. So if this is a 0, this is a 1, and here is a 0, what happens? So for this line, we only have one set bit, it is 1, and we're gonna do the XOR operation. Let me use another color. So for this line, let's just check this line, 0 1 0. There's only one set bit. If we do the XOR operation, 0 0, this is 0 0 1, it is still 1. So we didn't change the even or odd property. So this means it's gonna always be valid. Yeah. If we have 3 ones in a line, 1 1 is gonna be 0, 0 1 gonna be 1. Before it is 3, no, it is 1. Yeah. Before it is odd, now it is still odd. We didn't change the even or odd property. Yeah, so this means the final result gonna still be even. Yeah, I think I've already proved why we're gonna solve it like this. Basically, why we are solving the problem, we're gonna check the problem like this. Yeah, if we know why are we gonna solve it like this, let's just try to coding. Yeah, let's just make the coding a little bit easier to code. So I'm gonna use a counter for C1, C2, and C3, as this is a reference for the counter, so we need to copy a new counter. So we cannot use the C1 equal to C2 equal to C3 like that, because this is a reference, right? And we have to copy a new counter. So C1 gonna be a new counter, C2 gonna be another new counter, and C3 gonna be the third new counter. And I'm gonna define a function. Maybe I'm gonna call it check. And inside I'm gonna call a C. So C gonna be a I'm gonna call X and C. So C gonna be a counter and X can be ABC array. Now, yeah. So for the check function, actually I just want to update the counter. So for any number inside the X array, and the set bit, I'm gonna use the n.bit count. If the set bit number of set bit is even, so I'm gonna just use the counter with 2. 2 means even, so C2 gonna plus equal to 1, otherwise C1 gonna plus equal to 1. So this is not C1, this is just C. Yeah. Now what we're gonna do? We just need to update the counter. We can call the function, or we can put it like this. So for X and C inside, so this one gonna be A with C1 and B with C2 and C with C3. Yeah, we just need to run the check function with X and C. So in this way, we updated the counter of C1, C2, and C3. Let's just check what happens. Yeah, and let me just give a random return. It's gonna be 0. Yeah, so let's just check what happens for C1, C2, and C3. Yeah, now as you can see, C1, C2, and C3 actually it is updated, and this is really important for us to solve the problem, because for example for this 1, yeah, because 1 is odd, right? And so how many odd? Because 1 means odd, it is only 1. So for this 3 means even. So for 2 it means even. So the number of set bits is 2. So how many of them? It is 1. Yeah. So we just put it inside a counter, and then we just need to update the final result. So I'm gonna set the result. If it is even, I'm gonna use all of them. So it's gonna be C1 2, it is even, C2 2 times C3 2. Yeah. And then I'm gonna update the final result. It's gonna be C1. It must be 2 odd with 1 even. So C1 1 times C2 1 and times C3 must be 2. And I just need to plus all of them. Let me just copy and paste. Yeah, it's gonna be C1 1, C2 2. This one gonna be 1, and for this one, we're gonna make a C1 to 2 and C2 1 and C3 1. Yeah. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it. As you can see, it passed for all testing cases and it's pretty fast. Yeah. So the idea is that for such kind of problem, we are going to calculate the XOR set base. Normally, we cannot solve it by using the brute force. We have to use some mathematics skills to solve it. And for this one, we check the conclusion. We're going to use the number of set base. If all of them is even, it is okay. Yeah. If it is odd, it must be 2 of them going to be odd. Maybe this one and this one odd. Another one must be even. I mean, the number of the set base. There are only 2 different cases, and we're going to check the 2 different cases and find the final result. The time complexity is ON for this problem. Yeah, as you can see, for the check function, this is ON, and here, this is also ON. Yeah. So it means this one plus A plus B plus C actually is ON. So for the time complexity, it is ON. And the space complexity is ON as well. I think that's all about it. Thanks for watching. See you next time.